All right. Hello, everyone. It is the top of the hour, so I think we're just going to get started here. Welcome, everyone, to our fourth aquaculture webinar hosted by the Coastal Ecosystem Learning Centers, or CELC network. We're really excited today to host Dr. James Morris, who will talk to us about OceanReports, which is a spatial analysis tool for U.S. offshore aquaculture. And if anyone's on the phone, and just please remember to mute your speakers throughout the presentation, and we'll have some Q&A at the end where you have the opportunity to chat. All right, and so before we get started with the presentation, I just wanted to provide a brief overview of who we are and why we're doing this. Some of you may know this already. You may be part of the network, or you may have been on a webinar before. But for those of you who are maybe new to this, we are the Coastal Ecosystem Learning Centers Network, which is a consortium of 27 aquariums and learning centers across North America that have an annual visitorship of over 20 million people a year. So we here at the NOAA's Office of Education manages this network, and our mission is to function in a unified manner to engage the public in protecting coastal and marine ecosystems. And so about last year, we started this aquaculture initiative to increase the public's understanding of marine aquaculture. So we're hoping to work with our aquariums to educate the public about aquaculture, and that it can be a source of domestically produced, safe, and sustainable seafood, a way to conserve and restore coastal habitats, and it can also be a catalyst for economic development. So if you're not on a listserv or part of the network and you want to learn more about our aquaculture initiative, or really anything else about the CELC network, please let me know. Send me an email. I'm going to be providing my email again at the end of this presentation. So if you do want to learn more and be part of the listserv and stay updated, please let us know, and check out our website to learn more about CELC in general as well. All right, and with that, I'm going to introduce Dr. James Morris, who will be talking today about OceanReports. So Dr. James Morris is a marine ecologist with NOAA's National Ocean Service, National Centers for Coastal Ocean Science, where his research focuses on aquaculture, environmental interactions, siting, and sustainability. Dr. Morris founded the Coastal Aquaculture Siting and Sustainability Research Program that consists of multidisciplinary scientists who develop tools and provide services for coastal managers. They currently lead over 50 research projects around the U.S. on spatial planning for nearshore and offshore aquaculture, and they also do assessments of environmental interactions. Dr. Morris has cultured dozens of species of marine fish and shellfish for both laboratory experiments and seafood production, and has decades of experience in commercial fishing and aquaculture industries. Dr. Morris is also an adjunct assistant professor at Duke University and North Carolina State University, where he teaches and advises students. And lastly, in 2011, Dr. Morris received a Presidential Career Award from President Obama. So we're really excited to have him on today. And with that, I'm going to stop sharing my screen, and then James, you can start sharing yours. Give me 1 second. All right.
Okay, thanks, Maggie. Can you hear me okay?
Yes.
All right. So, thank you, Maggie and Christos and Lauren for organizing this, and more importantly for nagging me to participate. I really appreciate that. There's a lot of stuff happening now that's real exciting in the aquaculture world, and this forum that you have set up here is a very important one for communicating about aquaculture and outreach opportunities. And so I extremely value the aquarium network. I'm a regular aquarium attendee, and I understand and very much value the impact that aquariums have on public education, public perception of coastal and environmental and ocean conservancy issues, and we really need to do a better job on the aquaculture front. So I'm excited today to share with you a new tool, a new product that we've developed. It's the culmination of over 10 years, and we think around $10 million of science has gone into producing this tool, and it's a joint effort with the Bureau of Ocean and Energy Management, and in the Ocean Service, two program offices, the Office of Coastal Management and the National Center for Coast Ocean Science, or NCOS. And we have all three partnered together to bring this tool and to you and to the public of our nation, with a long list of other partners that have contributed and supported our program over the years, such as the NIMS Office of Aquaculture, the Department of Energy, and the list goes on. And we're very fortunate to have those strong partnerships. So I'd like to give you a little bit of context before we get into the tool and what it's going to do for us in terms of increasing transparency and awareness for aquaculture development. So the NOAA Aquaculture Program is a somewhat of a matrix program across 3 line offices within NOAA. For some of you that may not be familiar, we have aquaculture work happening within the Ocean and Atmospheric Research, or OAR, specifically in Sea Grant. We have a lot of education and outreach, research and development, granting opportunities, and those kind of things, and most important, and very importantly, extension. We also have aquaculture work happening within the National Fisheries Service, within the NIMS Science Centers and even regional offices that are responsible for aquaculture permitting. We see a lot of our research and development activities happening there, as well as science to support general coastal management, especially those that focus on habitat and protected species and highly migratory species interactions and such. A lot of regulatory and policy work is happening there at the headquarters level, as well as a lot of international coordination. Within the National Ocean Service, we've been partnering strongly for the last 10 or 15 years with Sea Grant as well as with NIMS to build a program within the Ocean Service to complement the work happening in Sea Grant and fisheries. But what resources that we've worked to bring to the table relate to ocean data, to coastal zone management, also relating to developing tools and providing services to coastal managers and planners that are specific to aquaculture. And so I'm excited to tell you that our program has matured a lot over the last 10 years, and that we're really working and having an impact in all of the regions of the U.S. and all the coastal ocean. So it shouldn't be really any new news today, because it shouldn't be new to you today, because there's been a whole lot of outreach around it, but it has been NOAA's policy that aquaculture development is an important thing to consider and to work on nationally. And we've recently seen, as part of the public listening sessions with the administrator of NOAA and the Secretary of Commerce, the release of a Department of Commerce strategic plan. In it calls for increasing aquaculture production as a national priority to address seafood security concerns and seafood trade deficit issues within the U.S. So we're fortunate this time to have strong support among our leadership for this aquaculture opportunity work within the U.S. And there's a lot of demand for information and factual information around aquaculture, and I see the aquariums and the aquarium network as being a critical educational partner in that initiative. So within our program, we work to help managers primarily and industry grow sustainable coastal aquaculture. So we work to understand, what is sustainability? What does it mean to you? What does it mean to the general public? What exactly are we talking about when we say, what is sustainable aquaculture? We work to bring that science to bear and to put that science on paper, whether it be review or assessing the current state of knowledge, or developing new tools that will document and better understand that sustainability piece. Whether you're talking about interactions with marine mammals, whether you're talking about any kind of effluent that may be coming from farms, whether you're talking about habitat value of farms or habitat impacts of farms, whether you're talking about the different types of water quality interactions that happen around farms. One thing is very sure, that aquaculture can be very sustainable, can be sustainable by anyone's definition, but then also there can be practices that are not sustainable. And we work to differentiate among those and to provide best practices from a holistic standpoint in terms of the whole ecosystem. So right now we're managing around 40 to 50 projects, depending on what you call a project. We're working along every coastline of the U.S. primarily, developing a lot of tools that focus on federal waters, Our major customers are federal agencies like NIMS or NOAA and the EPA and the Army Corps of Engineers. We do a lot of work with the Department of Defense in looking at aquaculture interactions with military areas out in the federal waters. We do a lot of work with state agencies as they are coming to us for federal level support, federal level resources for better understanding aquaculture and their various coastal environments. So I'd like to start out with a quote from a friend of mine. I captured this in the keynote address that Dr. Schubel gave at the aquaculture conference last year, where he spoke about the importance of planning. And he said essentially that the solution to sustainable aquaculture is responsible planning and siting of farms. Now, Jerry is a very much an advocate for sustainable aquaculture and has worked hard to share that message nationally. And we're very pleased that the work that we're doing directly addresses that responsible planning piece when it comes to aquaculture development. And I'm really excited today to be able to share with you a new tool that we're working on doing that. So what we've done is, and this is very much an ocean service directive and mandate, is that we work to gather coastal intelligence. Everything from satellite, ship-based sonar imagery of habitats or heritage sites, buoy data with our ocean observing systems. We have glider and autonomous vehicles programs that go out and collect. All of that information, all that coastal intelligence is gathered and into databases of data, and it becomes at some point big data. One of the biggest data sets in the world is for marine spatial data is marine cadastre. Marine cadastre is essentially a clearinghouse or a warehouse, I should say, of marine spatial data that exists within our Office of Coastal Management. And so what I want to show you today is a tool that's going to utilize that large warehouse of marine spatial data, and we've developed a tool that can help us with understanding and better understand our ocean neighborhoods. Well, before I get into that, though, I want to share with you some of the different types of spatial services. So we've worked to build a team that specializes in spatial science and spatial modeling for aquaculture. So we've worked to develop screening analysis that helps us better understand the ocean neighborhoods, as well as opportunity analysis where we can tie economics. A good example of this lately was some work that we've been doing with the Port of San Diego. The Port of San Diego is interested in, they manage essentially 40% of San Diego Bay. They have business interests. It's an interesting partner for us because it's a port. Ports are very important to the Ocean Service. We provide lots of services and products to ports, primarily to support navigation and the shipping industry. They came to us and they said, we would like to assess the opportunity for aquaculture development within San Diego Bay and the surrounding coastal waters. So we've worked with them to essentially map where there is opportunity for various types of aquaculture industries within their coastal ocean and inshore there within the bay. Obviously, that is a very complex bay. There's a lot of industry there. There's a lot of sensitive habitats. There's a lot of challenges there. But what we've been able to do is calculate the number of acres that could be used for cultivation of over 40 different species gear combinations. And then the information will then go into their overall planning process. Well, they'll take that into their business planning considerations. They'll look at partners they can bring in and industry they can bring in to make some of those decisions. That's what an opportunity analysis is, even to the point of projecting how much tonnage of seafood that could be grown and what is the value of that tonnage. We also work on what we call precision siting analyses, and I'm going to show you an example of one of those next. And then we provide support for state waters when states have spatial planning challenges that they're working on. This is the general spatial planning process that we follow. Generally, we work hard to identify the aquaculture goal. We then look at the area of interest that is in question. This could be the Southern California Bight, or it could be 20 miles from the Port of San Diego. That depends on the project and that spatial question that's being asked. We then go and acquire data. Sometimes we have to go get new data, or sometimes we can answer the questions with existing data. We go through data processing and making sure that it's the right resolution for the question that we have. And these are the types of data that are typically collected. We have military compatibility, navigation, industry data, protected species, habitats, and the list goes on. That information then goes into a siting and management process where we interact with working groups, coastal manager working groups, industry themselves, etc., and are able to eventually get to a site suitability analysis. So here's the diagram that shows the various processes in terms of from data acquisition. Sometimes coastal managers will say, you know what, we just want to be able to provide data to industry or to other coastal managers of our resources so they can make determinations or they can make decisions on what to go next. And so that sometimes that process stops just at the data acquisition phase. Sometimes managers will say, you know what, we really only want to look at where aquaculture is a bad idea and what spaces do we not have or that's incompatible with aquaculture. And we want to stop there, because if we go farther than that, then there's some inherent bias, or we could be perceived as being at fault if we say somewhere is available and it's not. But sometimes they're more aggressive and they say, you know what, we want to map where we could grow aquaculture, so we want to go to the next level. That's where suitability analyses or opportunity analyses, lead to final site selection or planning processes. So we've worked to provide some exclusionary mapping, screening analyses, siting analyses, and assisting with tool development in state and federal waters. These are some types of oceanographic or spatial products that we've been developing. Oceanographic data, working with harmful algae blooms and spatial data development, mostly for federal and nearshore waters in Florida. Screening analysis, precision siting analysis. We've developed a national aqua mapper, which is a data warehouse for aquaculture relevant spatial data. We've worked to automate the spatial planning process, which I'm going to report back to you today on this OceanReports tool. We've developed various guidelines for documents to help folks that want to do it themselves or developing an aqua mapper for state waters. We have guidelines that we can provide to you for that and to do it yourself. So here's an example of what would be somewhat of a precision siting analysis. This is for a farm siting project off the coast of Ventura, California. Here you can see the gray area here that I'm circling is the area of interest. These are 100-acre grid cells within, and this area was determined by the farm, by industry, as having the environmental characteristics that they needed to farm. This is where the depths occur. This is where the ocean current regimes occur. This is the distance from port that they would be willing to work, and within this area somewhere in this area would be 2,000 acres that they're interested in getting a permit for. So we work to map, the different major interactions that would occur within this area. Here you see trawling, track lines, you see major shipping channels, and then we have fishing effort here that you see with micro block data. It gives us a better understanding of that ocean neighborhood. We then would work to look at the suitability. So we're able to create spatial models that essentially assign a suitability value to every grid cell in that area of interest. And so when looking at just at the oil and gas data, if we have for example, if we have an oil platform there that exists, we're not going to put a farm over top of an oil platform. It's just not possible. You can put one beside it, but not necessarily on top of it. And so that space that that oil platform occupies would be incompatible with aquaculture development. So that, for example, would get a score of 0. In some cases, you have data that is scalar, where you have, let's say, for example, there's a marine protected area within that area of interest. Well, there may or may not be laws that restrict aquaculture development within that protected area. Maybe it's a national park, for example. And let's say that the laws don't exist that would exclude it, but we know it's a protected area, so it may be difficult to get an aquaculture permit within that protected area. In that case, we may give the score a 0.5, which means that it's not highly compatible, but it's not incompatible either. And so as you can imagine, we would go through all the various different data sets in the analysis and assign rules and come up with the overall suitability score for every grid within the area of interest. And that overall score is highly demonstrative of the overall likelihood of getting a permit within that grid cell space. So in this case, the greener the score, the higher the likelihood of getting a permit, and the more red the score, the harder it would be to get a permit. It doesn't mean that it's a no-go necessarily, but it means that it would be really hard. So it's a relative index of suitability. And you can overlay and summarize or get your cumulative score and then and set it to a relative sense. And you see that within that area of interest that there are some greener areas and orange and red areas that give you a general sense of the overall suitability of that ocean neighborhood for aquaculture development. So we then would work with industry to identify, and in this case, we're able to identify 2,000 acres up at the top left of this area of interest, and that they then take that information and they go into the permitting process with a much more informed place in terms of the ocean neighborhood and the likelihood for permitting. So that's an example of a siting analysis. I want to step back, though, and talk about screening, about looking at the ocean, about ocean space at the big picture and better understanding our ocean neighborhood. The best way that I can explain the tool that we've built is that we've essentially created a Zillow for the ocean, where you can go in and understand the ocean neighborhood at a very high level of degrees. But we think it's better than Zillow. And there might be an app out there for this, for exploring your own home neighborhood, but our app will actually tell you things like, where's the nearest school? And what are the teachers like there? And what's their score when it comes to, performance as a school? It'll tell you where the most closest grocery stores are. It'll tell you, high level of detail about that ocean neighborhood. But when it comes to the ocean, we're talking about where are the oil and gas pipelines? Where are the commercial fishing industries? Where are the shore-based infrastructure for that ocean neighborhood? And those kind of things. So I like to start out by saying, imagine if you could pull up a map and in seconds obtain a spatial analysis that's uniquely designed for any U.S. ocean space. And that is useful, that analysis is useful for all ocean industries. And you can do that over and over and over at no cost. This is essentially what we've built for marine spatial planning. We have essentially automated marine spatial planning. So we'd like to introduce to you OceanReports. It builds on the over 10 years of marine spatial data collection within marine cadastre. We've put together a 40 to 50 person multidisciplinary team of computer programmers, biologists, ecologists, engineers, marine spatial scientists, and have worked to basically create an app. We call it affectionately a blue big data app, where you can go in and select a part of anywhere in the ocean, anywhere in the entire U.S. EEZ, and draw a box around any ocean space that you're interested in, and within less than a second, you can get an automated spatial planning analysis for that ocean space that will place you at a point of awareness that you would have never had before. To do the level of analysis that this tool will do for you on the fly within a second, you would spend tens of thousands of dollars, possibly more than $100,000, to do this analysis. You would have to go after each data set individually. You have to bring it in-house into your GIS system. You would have to then analyze that data, display that data, and then analyze that data for the questions that you have at hand. So a couple things about it. This tool, we feel like it's going to be one of NOAA's major accomplishments for the year. It just came out last week in the White House's Science and Technology Highlights Report as providing a never before amount of marine spatial data to the public. We're going to see that ocean industries are going to use this tool, not just aquaculture, but many other ocean industries. GIS and environmental consultants will use the tool, coastal managers and regulators, coastal planners, educators, and the public. I hope that the aquarium network is going to use this. As they're talking about ocean conservation, you're going to be able to set up interactive opportunities for the public to use this tool, perhaps even in your aquarium, to learn more about your nearby ocean. And I hope that you're excited about that as you learn more about it. So what's the big deal? We feel like this is going to rapidly increase transparency about ocean space and even ocean conservation. The industries will be better informed. Environmental NGOs will be better informed. We'll have ENGOs that are going and speaking more intelligently about ocean space and about the types of interactions that are happening there. Coastal managers will save tax dollars and time saved. Consultants will save time and money and be more efficient at what they do. We'll see a decrease in the number of permitting false starts. I can't tell you how frustrating it is to be working in a permitting process when industry comes to the table and wants to proceed in a permitting process, but they're unaware of all the different conflicts of that ocean space that already exist. And they've already spent a lot of money, they've already spent a lot of time, and they're using taxpayer dollars and to start in that permitting process because they've been uninformed. So this is going to solve a lot of those problems, and then increase regulatory efficiency throughout the U.S. So how do we do it? We envisioned a tool that would automate marine spatial planning. We assembled the multidisciplinary team. We optimized data from marinecadastre.gov. We build an oceanographic data report from scratch, and I look forward to sharing that with you. We developed rules for each data layer. We built automation scripts, and then we worked with the design with the end in mind. So here's the front page. What we're going to do is we're going to go through a number of slides that just so I can point and click and show you some specific things, and then we're going to do a live demo. And I'm going to ask a question of you. Actually, we may do two or so. We'll see how much time we have. But I'll randomly pick someone from the audience. So hopefully we can do this. And we're going to ask you to tell me what part of the ocean would you like to learn more about. And so we'll do a live demo about that. Matter of fact, I'll go ahead and pick someone. I'm going to pick Cleet Otoshi. Actually, know Cleet. I trust him. He's a good guy. Cleet, I want you to tell me where you'd like to learn more about the ocean, and it can't be Hawaii, because I know you know a lot about that. All right, so if you look at, this is the front page of the OceanReports tool. I want to highlight a few things here. What happens is you are asked to go ahead and draw a custom area here. You can also view quick reports. These are canned reports that have already been created for specific regions or in parts of the U.S. The report topics include general information, energy and minerals profile, and natural resources and conservation, transportation infrastructure, economics and commerce, and oceanography. So you come to the map, and you're asked to draw an area and hit submit. So you literally go on the map, you scroll wherever you want to go, and you draw a polygon. You click, draw, draw, draw. I'm going to show you how that works in just a second. We also have the quick reports for the regions, and then there's a variety of display tools and functions here. You can zoom in and out to your area of interest that you've drawn. You can type in a place, and it'll take you to a specific location. Let's say you wanted to go to Boston, or if you wanted to go to Monterey, California. You know, places that are named on the maps. It'll take you there specifically. You can use the measure tool to make measurements. You can enter coordinates to create a polygon of any size anywhere if you know the GPS coordinates. You can change the base map. You can select a region. You can turn on and off map layers within the map, and you can get a quick report. So when we say infographics, this is it's an example of one that we're talking about. Now, this one doesn't have a graphic. A lot of our infographics actually have graphics. But what you're going to see with infographics is there's going to be a title within each of the reports. You'll have also the I button, which gives you additional information on the rules that was used to create that spatial analysis. You'll also be able to click on this over here that toggles among the layers that are being displayed. And on the map, those layers will show up on the map so you can see those more thoroughly. There'll be a description of that data. There'll also be the geospatial statistics that are provided there, and then you'll be able to expand the infographic. And then lastly, we have a rule that has been developed for that specific data set. Now, just want to emphasize to you, so what's happening here is we've created an app that when you select anywhere in the ocean, you're going to go out and collect and get an analysis of ocean spatial data, on the fly, customized for anywhere in the U.S. EEZ. We have had to create, thousands of rules that govern what's being returned for that spatial analysis. Some of these rules are very simple. For example, we want to know within any box or polygon that's been selected or been drawn, for this one, it says this is going to show us biologically important areas, BIAs, for whales by type within 10 nautical miles of the report area. So we had to debate and we had to, argue and to figure out, is 10 miles enough? Should it be 50 miles? Should it be 100 miles? Should it be 1 mile? There's been justification and science behind, all these rules that you're seeing here. All right, so for the next, here I'm going to go through each one of these chapters. I'm going to share with you generally what's going on. So general information, it's going to give you a report area, your depth and elevation. We've stitched together the highest resolution bathymetry data set that's available for the USEZ for this tool. So it's automatically, anywhere you draw in the ocean, you're going to get depth and elevation, you're going to get depth. It's going to tell you the populated places. It's going to tell you your federal and state county jurisdictions. It's going to tell you your congressional and legislative districts that are nearby within that space. It's going to tell you the federal statutes that govern that space. It's going to tell you about your tribal lands that are nearby. For energy and minerals, here's a list of things that you're going to see. You're going to see the wind potential, planning areas, and energy leases. You're going to see the oil and gas potential, planning areas, and leases. We're going to show you where the energy facilities are within that, nearby with that ocean space. We're going to tell you where the sand and gravel leases are, if there's any beach renourishment projects nearby. What is the sediment like, the superficial sediment texture, and are there any disposal sites within that ocean space? For natural resources and conservation, we're going to give you analysis of endangered species and critical habitat designations. We're going to tell you if you're within a habitat area of particular concern. We're going to list for you the highly migratory species. We're going to tell you about the marine birds from the Audubon Society data source. We're going to show you where protected areas exist and whether or not there's any within that space that you've drawn. We're going to show you where artificial reefs are mapped, the corals, deep and shallow, and we're going to also look at those BIAs for whales. Under transportation infrastructure, it's going to show you where the vessels are, where offshore, where the shipping lanes are, where the vessel traffic is the highest by that AIS data. We're going to show you where the pilot boarding areas are, ports, anchorage areas. We're going to show you where military areas are and where those unexploded ordnance zones are that we are very scared of. We're going to tell you where the formerly defense sites are, the wrecks, cables, wasteful outfalls, if there are any other aquaculture facilities there, the lightering zones, and all that kind of stuff. So one of the examples, when we go into the Gulf, we'll show you the oil industry there. For economics and commerce, you'll get an analysis back of the ocean job contributions of that space and the contribution in terms of GDP to the ocean economy. There'll be some census statistics, and we'll also show you what the fishing economic value of that ocean space. And then lastly, we'll show you oceanography. We're very excited to have partnered with Esri's Ocean team to be able to utilize the Ecological Marine Units program that they have, where they've essentially modeled the ocean and they have current and temperature and salinity and nutrient data that NOAA and Esri has worked together to build the most comprehensive ocean data set when it comes to oceanography. So within the ocean space that we draw, we're going to get customized reports of wave height, wind speed, current speed and direction, sea surface temperature, water temperature, salinity, nutrient information, light attenuation, chlorophyll, and such. So I hope that you're excited to see this in action. So what we're going to do is,
let me change the share screen. Please stay tuned for our next webinar, which will hopefully be in a couple months, so late April or early May. We're hopefully finding a speaker soon for our next webinar. Again, if you are not on a listserv and want to stay in touch about the CELC network and the CELC Aquaculture Initiative, please email me and I can put you on a listserv and or get in touch with you about what else we do. And Christos and Lauren are also part of the CELC network as well, and they'd also be happy to answer any questions you may have. And thank you to both of them for helping out today. And special thanks to James again for presenting on a really awesome topic and a really great tool that we're excited to see. All right, well, that's that. Thank you again, and I'm going to end the webinar today.
Bye, guys.
Thank you, Maggie.
Thank you.
So, okay. Yeah, fair.